All right, so y'all, we're going to continue in 9.6. So y'all, yesterday we did the first half of 9.6 solving exponential equations. So today we're going to solve logarithmic equations. All right, so what helps us in this section, like we had the base exponent property yesterday? Well, today we got what we call the log base property. And y'all, this says if a log base A of x equals a log base A of y. So if you got two sides equal and they both got the same log base, then that means this result equals that result. So then x equals y. Just like yesterday, if you could write something with the same base, then the exponents were equal. Well, that's the same thing here. If you can write them with the same log base, then those results are equal, okay? So the steps to solving, first thing I do, I look on either side of the equal sign, and I combine logs if needed. On either side of the equal. So if I got a log A something plus a log A something on one side of my equals, I need to combine them into a single log using either my product rule that I learned yesterday or my quotient rule. So at that point, we got to look at it and say, do we have a log base equal to a log base? So that we got this going on up here. So if we got a log base equal to a log base, if yes, then set the results equal to each other. And solve for the variable. So if I got this going on, I set the results equal together, which is the x equals y part. At that point, solve for the variable. If we do not have a log base equal to a log base, then at that point, we rewrite as exponential equation. So this is doing the stuff where they had us in section 9.4 convert from exponential to logarithmic or from logarithmic to exponential. So let's do that kind of stuff when we rewrite it as exponential. So remember, rewriting as exponential, you'll have the y equals a to the x. Okay, we'll change it from a log into an exponential equation. At that point, solve for the variable. Now, the difference on these logarithmic and the exponential equations is on logarithmic equations, you gotta check the answers. And the reason you want to check your answers is because we cannot take the log of a negative number. And y'all remember, if you remember 9.4, when they had you taking the logs of the negative numbers, we said that those do not exist. So you cannot take the log of a negative number, okay? So that means we exclude those negative answers. Okay, so if I get a positive answer and a negative answer, I'm going to exclude that negative answer because I cannot take the log of negative numbers, okay? All right, y'all, so these are the steps I'll follow. I'll see if I got a log base equals log base. If it does, then I can solve them pretty quick. If I don't have a log base on each side, then I'm going to be rewriting them as exponential, okay? All right, y'all, so let's start these out. And these will be just like yesterday. They'll say solve for x. So y'all, this one, they got a log base 2 of x equals 4. So I've got a single log on the left side. So I don't have any logs on either side to combine because I got a single log here. But y'all, I don't have a log base on each side. So since I don't have a log base on each side for this problem, I'm going to rewrite as exponential. So to do that, I take the base, which is the 2. The exponent is the 4. And that equals the result, which is the x. So remember, the base of the logarithm becomes the base of the exponential equation. The log finds the exponent, so this becomes the exponent for the exponential. And then this result here, the x, becomes the solution to the exponential. And y'all, to finish this, all I got to do is figure out 2 to the 4th. So 2 to the 4th equals 2 times 2 times 2 times 2, which equals 16. So 2 to the 4th is 16. That equals my x. So if I have to check this on my calculator and do a log base 2 of 16, well, let's see what you'll get. So this one, I'm just checking it. Whoops, I don't got my calculator on, my bad. I'll just show you on my handheld one here. So remember, I can go to log base, math, arrow down to log base, hit enter. My base was a 2. My result was a 16. And y'all, when I hit enter, I get that exponent of 4. So you can check these answers and see that they do check out for you. All right, y'all, this next one is really similar to that one. Let's see, I got a log base 4 parentheses 5x minus 4 equals 1. Now, if you notice, once again, I got a single log over here. I don't have logs on both sides. So I'm going to do the same thing I did here, and I'm going to rewrite this as exponential. All right, so my base is the 4. So bring down the 4. The exponent is the 1. So y'all do the same thing I did here. Bring down the base, the exponent. That's going to equal the result. Well, my result is the 5x minus 4. All right, to solve this, 4 to the first power is 4. Y'all solving this for the x. We're going to add 4 to both sides to get the 5x by itself. So 4 and 4 give me 8 equal to my 5x. And y'all, last step, divide both sides by the 5. So those cancel, making that a 1x. We can't do nothing to the 8/5. So that will be our final answer. Now, y'all, so that's the thing on these. So let's show you, let's change it up a little bit. So watch this one. I got a log base 4, x plus 21 minus a log base 4, x plus 5. That's going to equal a log base 4 of x. So I got logs on both sides. I got logs everywhere. But my very first step was to make a single log if I had more than one log on either side. Well, I got 2 logs on this left side. Now remember, since they're being subtracted, I would write this as a quotient. So y'all, we're going to use the quotient rule, okay, since they're being subtracted. So you bring out that log 4. The x plus 21 goes to the top. This factor was being subtracted, so the x plus 5 goes to the bottom. And then that'll equal the right side, which is a log base 4 of x. So if you got more than one log, you gotta write it as a single log. Now notice, this log base 4 matches that log base 4. So the log bases match. So we said if the log bases match, we can set this result equal to that result. So x plus 21 over x plus 5 equals x. All right, y'all, so to solve this, you can make the x look like a fraction by putting a 1 here. But this is why they had us do that support part where we was doing the cross multiplying. So when you got a fraction equal to a fraction, cross multiply. 1 times x is x. 1 times 21 is 21. That's going to equal the other side where I take the bottom and multiply by the x. So the x times x is an x squared. And then the x times 5 is a 5x. So since we got an x squared in here, and x's and numbers, we want to get everything on one side equal to 0. So I'm going to move everything to the right side because of the x squared. So I'm going to subtract the x from both sides. And we're going to subtract 21 from both sides. We got to move both of these in order to get a 0 over there. So on this side, bring down the x squared. 5 minus 1x leaves me 4x. and then I got my negative 21. So y'all, this is why we had to learn our factoring yesterday, because this one's going to need factored. X squared is an x and an x. Now y'all remember, if you don't like factoring, you can graph that and get the two answers by graphing, okay? If you graph this in y equals and get those two x-intercepts, you'll get the same answers I get, okay? All right, y'all, that's negative. Anytime the last number is negative, you got unlike signs. And then I need factors of 21. That'll subtract and get me 4. So that'll be 3 and 7. 7's the larger number, so it's positive like the middle. All right, so it's factored. We would set both of them equal to 0. So you know the person, I subtract 7. I get x is a negative 7. Second one, I add 3. I get x is a positive 3. But y'all, the main thing is this negative 7. If you try to take a log base 4 of a negative 7, calculator's going to give you an error message. So we cannot keep the negative answer for this one. So the only answer would be the x equals 3, okay? All right, y'all. So remembering, calculator, put this part right here in y equals. So to do that on the calculator, y equals, I to put in that, and then graph. So that means it would have crossed over here at negative 7 and positive 3. Now I don't know how the graph actually looks, but it should be something like that. But you're looking for this negative 7 and 3. These were the solutions. But just remember, you can't keep these negative answers, so throw them out, and we can only keep our positive answers. Yeah. Oh, y'all, so that's just other ways to solve them if you don't like factoring. Or you can use a quadratic formula if you like that, okay? But woo, that quadratic formula is a little trickier. And y'all, that's basically what these problems are doing. Just throw the logs on different parts, like a log base 4 of x plus 1 minus a log base 4 of x equals 4. Similar to the last problem, but I don't have a log on the right side. I just got a number here. But I do got 2 logs on the left side, and we got to take all this and write these 2 logs as a single log. And they're being subtracted again, remember? So it's going to look like a fraction. So bring out that log 4. The x plus 1 will go to the top. This factor was being subtracted, so that x will go to the bottom. And y'all, that'll equal the 4 on the right side. So I don't have the logs on both sides, so I'm going to have to rewrite this one as exponential. So the base is the 4. The exponent is a 4. And 4 to the 4th is going to equal the x plus 1 over x. So y'all, what I would do first, I'm going to make this look like a fraction, but first I'm going to figure out what 4 to the 4th power is. 4 times 4 times 4 times 4. If you multiply all that out, you get 256. So I'm going to replace that with 256 equal to my x plus 1 over x. Now to solve this, remember, I'm going to make this 256. I'm going to put a 1 under it, make it look like a fraction. So then I can cross multiply. 256 times x is 256x. That'll equal this x plus 1 times 1. So x times 1 is x, plus 1 times 1 is 1. All right, so I got x's on both sides and a number. So I'm going to move all the x's over here by subtracting an x. So y'all, 256 minus 1 leaves me 255x equal, those cancel to 1. And then let's see, last step, divide both sides by 255. So all those 255s cancel, making that a 1x. Oh, and we can't simplify this, so it's going to stay a 1 over 255. Okay, so the trick on this one was to come up here and write the two logs as a single log. Now, if you're noticing, they've been giving me a lot of these with the logs being subtracted. But y'all, the next examples, my last two examples, they're going to make them where the logs are being added, okay? So here we go. Log base 2 of x plus a log base 2 x minus 1 equals a log base 2 of 6. So this, see, they're being added this time, but I got two logs over here. So we're still going to have to write these two logs as a single log. So bring out that log base 2. So they're being added this time. So since they're being added, I write them as a product. X times x minus 1. And that'll equal the right side, log base 2 of 6. And before I go further, I'm actually going to multiply this stuff out. So that I bring down my log 2. And then I'll put this stuff in parentheses. X times x is x squared. X times negative 1 is a negative x. All that equal to my log base 2 of a 6. All right, I usually just multiply this out so that when I get to this point, my log bases match on each side. So see, if they're both on the same side, you write them as a single log. If they're on opposite sides of each other, and we got the log bases match, that means that the x squared plus x, the x squared minus x has to equal this result, which is a 6. So y'all, we got the x squared again, and we got the x, and we got a number. So that means that we got to get everything on one side equal to 0. So we need to subtract 6 from both sides. I get x squared minus x minus 6 equal to 0. All right, so at this point, you can go to y equals and graph this to get the two answers. I'm going to factor it again. So x squared is the x and the x. The last number is negative, so I got unlike signs for my factors. I need factors of 6. That'll subtract to get 1. So that'll be 3 and 2. The 3 is bigger, so it'll be negative like the middle. But I'll tell you a trick. Your number you're factoring is 6. It is negative technically. So how can you get a negative 6 multiplied? You can do a negative 1 times 6, a negative 2 times 3. You could do a 1 times negative 6, or a 2 times negative 3. Just make sure you got unlike signs. And the only way to get a negative is these 4 different ways, okay? And you needed them to add to a negative 1. So the only ones that added to negative 1 were the negative 3 and 2. Okay? Now, set both these equal to 0. And we'll solve for the variables. So y'all here will subtract 2 and get x is a negative 2. On this one, we will add 3 and get x is a positive 3. But y'all remember, if you plug this negative 2 back in up here for this x, it's not going to let you evaluate that. It's going to give you an error message. So once again, you got to get rid of that negative answer. And the only answer is your x equals 3. And that's the main thing you got to look out for on these. When you got 2 answers, get rid of that negative one, okay? And also, I got one more. All right, so let's see. We got a log base 2 of x plus 2 plus a log base 2 of x minus 2. All that equals 5. All right, y'all. So I don't have a log on this side, but I do got 2 on the left side. So these 2 logs I'm going to combine in a single log. Now, they're being added. So since they're being added, a single log, they're going to be a product. So bring out the log 2, and then we got an x plus 2 times x minus 2. All that equal to 5. Now, I'm going to FOIL this stuff real quick because you always want to multiply your stuff out before you do your next step, okay? So bring down that log 2. X plus 2 times x minus 2. Conjugate pairs. So multiply the x times x and get an x squared. Multiply the 2 times negative 2 and get a negative 4. All that equal to 5. So remember, on conjugate pairs with a FOIL, I don't have to do nothing but the x's and then the numbers. Okay? Because 2x and negative 2x are going to cancel every time. So just remember on conjugate pairs, you can shortcut that foiling process. All right, y'all. So it don't matter if you got whole numbers here, real numbers. You can have radicals here. You can have imaginary numbers, but conjugate pairs always canceled out those middle terms. Okay. All right. So right here, I don't have a log base on this side. So my only other choice is to rewrite this as exponential. So my base is a 2. My exponent is the 5. And that's going to equal that result, x squared minus 4. So y'all, 2 to the 5th equals 2 times 2 times 2 times 2 times 2. Multiplying all these 2 together, we would get 32. So replace 2 to the 5th with 32. Now notice the difference. Now I got x squared in numbers. There's not an x term here. So all I got to do to this one is move the 4 over here and do square roots. Okay, so 32 and 4 give me 36 equal to my x squared. So y'all, that's why you got to look at these and determine, how do I need to solve it? What kind of terms do I have? If you only got an x squared in numbers, the best thing to do is to square roots like we're about to do. If you got the x squared and an x term, I would solve that by factoring out the greatest common factors, okay? Um, if you got the trinomial like I did a while ago with the 21 at the end, um, you got to either factor them or you can do the quadratic formula. Um, all right, y'all. So to solve that, I'm going to take square roots of both sides. Remember, square root of a number is a plus or minus. So that this gives me a plus or minus 6, and the square root of x squared is x. So I get x equals 6, x equals negative 6. But remember, I cannot keep the negative answer. So the only answer would be x equals 6. Now, y'all, let me show you the other way I would have done this. If you wanted to graph it to get your answers, you would move the 32 over here so that you get 0 equals x squared minus 36. You want everything on one side equal to 0 when you graph it. But y'all watch this when we if you was to graph this now in y equals, when you did that graph, you would notice that it's crossing over here at negative 6 and positive 6. Okay, so, and we would remember, hey, I can't take the negative x's, so we would cancel that one out and only go with our positive answer, okay? So many ways you can solve these once you get these quadratic equations. Um, it's just whatever you like doing. Do you like square roots? Do you like graphing to get your answers? Do you like factoring? Um, this one problem I could have solved 4 ways. I could have done the square roots like I did. I could have graphed it. I could have factored that, or I could have used the quadratic formula. So you're not limited, y'all. Use what you like the best to solve these, okay? All right, y'all, hang on just one second. We'll let y'all copy that. I'm looking at something real quick on our next section real quick. So I'll let y'all catch up on your notes. Alrighty, y'all. So that was 9-6. The half we did yesterday was exponential. The half we did today was the logarithmic, okay? Um, I'm gonna wait till Monday to do 9-7. It's a fairly quick section, and then I'm gonna try to go over any issues y'all might have um heading into this fourth test, okay? So y'all, the main thing, remember y'all got test 3 due Sunday night, okay? We'll finish out 9-7 on Monday. Review for test 4 on Tuesday. Wednesday, I'm reviewing for the final exam.